kind of kick things off.
Okay.
And I guess we can start the kind of the meeting. So thank you everybody for coming. The meeting is recorded. We now have the capability to upload these meetings. So post the meeting, I will download the recording and upload it to YouTube for everybody. So anybody who can't attend because of the time zones and things like that will be able to see this. I do see that we have a live stream, so Lee is on the ball there with that, so that's all exciting. And today, I want to say thank you to the team behind Sermant, who are coming to present to us. Sermant is a Sandbox application. I will paste the link for everybody. Sorry, I'm just going to copy that link into the Zoom chat. But it's Sandbox application 99. So anybody who's watching the recording will we'll stick the link in the description below, like and subscribe, all of that good stuff. Yeah, if you haven't already, please update your name on the attendance list inside of the meeting notes. I will do my very best to try and capture things as we're going along, so I can send out synopsis post meeting. But it's not my 100% my forte, so I will have to apologize a little bit. The other thing that I want to kind of look at is where we're actually looking at a new process around the way that projects are presented to the TOC for inclusion. Now, this doesn't change anything for you. What we're trying to do is we're trying to run through a more sort of formalized process in terms of a template. And what that means is if we capture all of the information from your presentation in that template, along with the questions that we have, we can then condense that to provide to the TOC. So when the sort of the board meets, which is August 13 for the next one, I'm not certain whether Sermant will be on that list. I think there's already a bunch, about 10 projects which the TOC want to get through, but we'll be on the next one. Then we sort of capture all of that information and we provide that to the TOC, and it just makes their life easier when they're trying to kind of make a decision on qualification around acceptance. And obviously our job as TOC, as tag chairs, is to facilitate that you get accepted to a Sandbox, and we'll work with you to make sure that any information or any of the sort of bits and pieces around the certain criteria, acceptance criteria, is met before that TOC meeting, so that hopefully the TOC meeting is a rubber stamp as opposed to a great deal of questions. Now,
that sounds good. Okay.
That being said, let me just get my document open. Okay, awesome. And I guess what I will do is I'll just over to you all. I'm excited. I think this looks a great project, and I'm really interested to kind of hear about the history and all of the bits and pieces that kind of led you to where you are today.
Okay, so should I start to do a speech?
Yeah, 100%, please.
Okay.
And then feel completely comfortable. You should have the ability to share your screen if you need to do so.
Okay, so can you see my screen now?
I can indeed. Looks great.
Okay. So I'm not sure if my network looks like my network is not very stable. So if you do not hear me very well, let me know and I will try to say again. Okay, if you are not hearing me very well, because the room is telling me that my network is not very stable. Okay, so okay. So
yeah, I can hear you. I will if you drop out, I will interrupt. So don't worry.
Okay.
You're all good for the moment.
Okay, thanks. Okay, Sermant So our proxy service mesh based on Java bytecode enhancement technology agenda. And let me go this background and motivation. Okay, so we all know that service mesh this service mesh architecture has a like 5-6 years history, right? So firstly we have this Envoy technology. I think Envoy is a very fantastic project because I think it's a first open source project for service mesh architecture. So the benefits of this Envoy is that it's a language independent, and this project, its architecture is it can be decoupling from the application, which means that so no matter what your application is written by any language, then if you do the standard microservices network interfaces, then Envoy will help you do the microservice governance, right? So, but the Envoy's limitation is that at least something here listed here is the performance overhead, extra resource cost, and architecture complexity. So I think that's several. That's the key reasons why Envoy is at least not as popular as expected, at least here in China. Because most customers, when they are trying to adopt the Envoy, so this problem will happen, especially like this performance overhead, right? So each time you end one Envoy, it will introduce like a 1 or 2 milliseconds delay. Okay, so then we have this source mesh with the proxy-less and gRPC architecture and the eBPF Cilium architecture. I think these 12 architectures both solve the performance overhead and the resource cost in some ways. For example, proxy-less gRPC architecture, because we put this server microservices governance function in this SDK, then it means that nearly no performance overhead is introduced, and also I think the resource cost is very low. But the biggest problem of this architecture is that it's tight coupling with this application, which means that every time if you are going to introduce a new feature for this service governance function, then you need to have this application build a new image, right? And so that's why I think it introduced more effort. It costs more effort for the developer. And then we have this eBPF Cilium project, and it also solves the performance and the resource cost in some way, but also I think the biggest problem is its architecture complexity, right? Then we start to think about how to solve this problem. That's why we think about to do this Sermant project. We think about to solve the problem with the Java agent. The reason why we think about this Java using Java agent is because the idea was inspired by many of these APM service provider 3 or 4 years ago, because APM area, including the Dynatrace or App Dynamics, and even some of the very famous open source projects like Skywalking, and even today Open Telemetry, right? Open Sensors, so all these projects are using Java agent to dynamically instrument the Java project in order to solve observability problem. So that's why we think that why do not we use Java agent to also solve the microservices governance problem, or to achieve the microservices governance function. So that's why we think about putting these functions in the Java agent. So significant differences of this architecture comparing with other 3 ones is that the Java agent can run in the same Java process of the microservices. So that's why we get these 4 kinds of benefits. First, high performance. because it's a aspect-oriented programming architecture. No proxy component is involved, so the performance can be very high. Nearly no more latency is introduced by this architecture, and also it's a very it's a resource efficiency because it's a no standalone process comparing to this Envoy project. Rich function because this all these service governance function is embedded in a process. So it means that we can do a lot of things. For example, distributed tracing, because we need to pass a trace ID in different microservices process, right? So Envoy cannot do that. And the eBPF can also not do that. But Java agent is able to do that because this logic is embedded in the process. And the zero code change comparing to this gRPC architecture, because we are using Java agent to dynamically instrument this Java process. So we have these four kinds of benefits. But there is a limitation of course for this project because it's Java only. But we think it's okay. We think it's okay because at least here in China, also like in ASEAN, most of the microservices, at least here, most microservices are developed by Java, in special by Java for the enterprises business microservices process, especially in the banking industry. I would say in the banking industry here, if you we actually visited some of these banking customer. At least in China here, nearly more than 90% of this bank's application is developed by Java. Java is actually here very popular for the microservices business process development. Okay, so that's an initial motivation. So what is Sermant? This is a very high level of this architecture description. So of course we have this Sermant agent, which is leverage the Java agent. So most of the function here, actually, so more than 90% of this code or in the Sermant project is here in Sermant agent, because the service governance function here is here. And we also have a dynamic configuration center, because we know that for microservices governance, for example, no matter like load balance or like distributed tracing or whatever, so we require a dynamic configuration ability in order to dynamically adjust the function for the microservices governance. And we don't want to make a new one, because so initially we just we are thinking about the integrate the open source project. So that's why we choose like a Zookeeper, Narcos, or Key, or even Isto today. So which means that we just put the configuration rooms in this open source projects in this config center. Then we are able to to push this room into the Java agent, so that these governance functions can be adjusted dynamically for the Sermant. And for the Sermant backend, why we have this component is because in the for the earlier adopters of this project, our customers' voice is that so when they are trying to use the Sermant agent, one of the problems is that they ask us if the application is going wrong, how can they make a very quick a judgment, or how can they make a quick troubleshooting that whether the problem is lies in the application itself or some agent. So that's why and also how to better manage the Sermant agents. So that's why we have this Sermant backend. Its function is very straightforward. So Sermant agent will push all these configuration and heartbeat events to this Sermant backend. So with this backend, we are able to understand like how many agents are running in their like data center, and what versions are these agents, and if they are if these agents are healthy or not. So that's what the Sermant backend do. So that's a very high level of this architecture, and as I said, so because most of the functions lies here in the Sermant agent, so I'm going to expand this architecture a little bit in this following slide. So as I said previously, we have the dynamic configuration center, we have the Sermant backend. Now for the Sermant agent itself, we have two layers. We have a plugin layer and a framework layer. So the core idea of this Sermant agent is that we want to make all these functions as many plugins, so that for different scenarios of our customer, they can turn on or turn off any individual plugin or say individual functions according to their real business needs. And the reason we have this framework layer, the core idea of this framework layer is trying to make this plugin development more easily. So I listed here some of the plugin functions. I think what you see is what you get. We have a monitoring plugin, route plugin, flow control plugin, folder injection plugin. Folder injection plugin actually it's like a chaos engineering functions. So and for this framework layer, I also listed some function here. So for example, class isolation. Why we have this class isolation here is because in Java world, if you go directly programming in a Java agent without do any more things, the most likely you will have a problem for Java class conflicts. This problem is caused because of some of the fundamental theory of how Java works, because of this class loader things. So that's why we do a lot of customization in Sermant's agents plugins class loader to make sure that all these class either from plugin or from framework layer or say even from the business layer, they do not conflicts with each other. Each one with their own class loader, and so they can work well with each other, and also pluggable, as I said before. So each plugin can be turned on and turned off. And one more thing we just did for this architecture is that we make a function that any of these plugins can be dynamically updated. So for example, if you have a new version of the flow control plugin, so technically we are able to turn off the flow control plugin and put a new version there and turn on the flow control plugin, and then you get a new version of flow control plugin, and during all the process you do not need to turn off the application. Okay, so which means that the function can be updated dynamically. And self-observability, of course. So for in this framework layer, so all this agent status will be uploaded to the backend. And for example, so we also add some functions that if any plugins that they are writing logs with like a warning or error event, then these events will be uploaded to a backend so that we can know, we are able to know that the agent is doing something wrong. And of course, this XDS protocol. So that's what we did earlier this year. So by supporting this XDS protocol with YSTL, and so this servant can be running compatibly with a YSTL environment. Okay, and that's architecture. And what can Sermant do? As I listed before, so it's a microservices governance so basically what all these microservices governance function can be done in the Sermant. So I just list some key scenario here. So one is what we call is the architecture transformation or also architecture upgrading. So what is the architecture I list here is previously, you know, this typical load balance architecture. If any service like a client service is trying to call another service, right? So in the old days, they call it via a load balancer. So for example, the service A, they call like a URL, right? Uh, uh, URL, and they look up the IP they look up the IP from the DNS to locate the load balance, and it call the load balance. Then load balance will route the call to another target services or another instance. So I think this architecture is even today very somewhat popular in some of our China's IT industry. For example, also inside Huawei, some of IT department is still using this architecture. And then the problem becomes that if this architecture is going to go to become a cloud native architecture, then how do we change the architecture? And so our thinking is that by using Sermant agent, they do not change any line of code. So for example, if they use a Sermant agent here, Sermant agent will dynamically instrument the application. So once the application start up, right, then Sermant agent will try to register the IP address to the service register center with the service name, of course, which can be defined by the admin. And if the service A is trying to call the service D, right, and by using certain URL or say domain name, then some agent will capture that and will locate the IP address from the service register center. Then the rest of the thing is to do the load balancing, rate limits, or circuit breaks, and things like that. So that's a typical scenario. And another thing I want to introduce is what we call so-called end-to-end gray release. I think we are all familiar with what gray release is, right? I think, for example, Envoy is pretty much good at the gray release. But what end-to-end gray release is that it actually do something more. For example, we have a function that is a new function for the whole application, right? So which is built by two microservices A and C for the version 1, and we want to do a gray release, and so what we do is that we identify certain flow at the workflow or service call at the beginning of this application, and we tag that flow, and that flow with that tag will go through its whole life cycle, and just the theory is just something like the distributed tracing with a trace ID. So we define the gray release policies that, for example, if the flow is with a user tag full, right? So all of this workflow will go to the version 1 if there is a version 1 instance. So in this typical case, the service A, we have a flow that is marked or is tagged with full, right? And then this service A will go to B because B does not have a version 1. Then but then later for the third app microservices call, right? And because it has a version 1, then it will be routed to the service C. So that's what we call end-to-end gray release. Once again, the gray release it does not only deal to not only deal to two microservices, but it also can deal with multi microservices for the whole chain call, because it is able to carry this user tag with of this user context during the whole service calls lifecycle. That's what we call end-to-end gray release. And of course, there's grace for shutdown. I think we also know about that. So So I'm going to pass it in order to save time. And another thing I want to introduce is how similar can work in Kubernetes.
Just really quick, there's some comments in the or questions in the chat. Wondered if you wanted to review those really quick and.
Pardon me?
Yeah, Yang, one of the questions in the chat just has to do with the full functionality of the gray release capability. It sounds like, from your description, it sounds like that's something of a multivariate release process. So you're able to like tag
This
a
one?
user. Yeah.
Oh.
And so are there, outside of tagging, using user context and user tags to help with traffic flow or to help identify which traffic should be canaried or gray released, are there other metrics that users can define to dictate?
Yeah. Yes. Okay. So your question is that I just did list some example here, like user tag full. So your question is that if this tag or this ID can be defined in a more flexible way or can be customized. Is that a question? Is that the question?
Yeah. Or I'll tack this on to help characterize it slightly differently. I suspect that the answer there is yes, like resoundingly. So that's great. But adjoining something like the tag, are there any metrics like literally in terms of metrics that you might track, like certain performance metrics that you might be able to track, or that this gray release functionality might also be able to say, like, hey, for these users, or these flows, these traffic flows that have a particular tag, maybe sometimes they succeed, or sometimes they fail, or maybe sometimes they're slow, and so I was just
okay. You mean the basic observe? Okay. So we have yeah, we have done basic observability function in Sermant. But for your specific question about like a tag, any very I think your question is if a certain specific flow that with specific tag, you want to understand that specific kind of flows matrix, right? So if for that questions we haven't done this yet, but I think this architecture, if our user want these functions, we can quickly implement that. But for now, I think I think I list some functions here. So now we have a very basic service matrix monitoring, which means that we have like a QPS, TPS, response time, error rate matrix. Just the specific function that you described, we don't have yet. Okay. Does that answer your question?
It certainly does, and Nick might have more to add. I'll just say,
yeah, I just had a follow on to that, which just strikes me as really interesting as well. Because the agent is in process, therefore it's in line of the process. You can actually forward the context. So for example, if you have an Envoy proxy, the Envoy proxy could capture an inbound context. It could pass it to the upstream, but the upstream code still has to be responsible to take that context and pass it to the downstream.
Exactly. Yeah.
Yeah, because the proxies are running out of context. They're connected over the network. Because you're in line and because you're in an agent, you can basically append that context to each request call in process. So it does enable that kind of like that zero-based approach to have you calling it user context here, but it's kind of passed with every request.
Now, yes.
So one of the reason I bring that up is tracing. Tracing is obviously I wouldn't say it's a huge complexity, but I think in terms of tracing, one of the things that you have to do in something like Go is you've got to do certainly a little bit of manual work to automatically augment your method calls and things like that, because you're taking the agent-based approach, and because you've already mentioned the kind of the APM-based approach. Are you also looking at the ability to be able to, you know, to automatically generate trace trace statements, which could be then pumped out into an OTel collector? Or is that not part of the project? Right.
Okay. So so you are asking that if we are doing any distributed tracing function in our project, is that a question?
Well, yeah, I was wondering whether your kind of the agent is, if I'm jumping ahead of myself, then, you know, we can kind of come to that later on, but it just feels like a really great integration because of the way that the agent-based approach is working.
Yeah. So yeah, we have this information listed in the slides. So basically, we are thinking about maybe later on we can integrate the open telemetry SDK from the Java language to integrate this open telemetry SDK in the Sermant agent, so that the Sermant agent is able to do the distributed things, tracing things. So the reason why we haven't implemented it yet because in the Java project, I think there are already some famous open source projects that can deal with distributed tracing problems with using Java agent. For example, OpenTelemetry is able to do that.
Yeah.
And also in China, there is a very famous project called Skywalking. It's also able to do that. So that's why we think that the distributed tracing function is not a priority one, because because the developer has candidates, you know, they have other choices.
Yeah.
But the bigger problem is that you know, for other like service governance or service management functions in Java, or they do not have a good way you know, to in order to achieve you know, zero code change.
Yeah.
So that's why we put it as a first priority one, even for the XDS product support. But once again, we are thinking about maybe support open telemetry maybe next year. We think that it's also important, although it's not our priority one, but priority one. But we think it's also important because once we support you know, both distributed tracing and XDS, then the user can just use one single Java agent to do all the things, which can save the, you know, performance and save the resource.
Yeah. I think, I mean, I think for me as well, there's a lot of interest around OTel sort of being agent-based as well, because there's, you know, there's information around potentially like the load balancing. If you have a retry or something like that, which is happening at a load balancer level, I don't know, I'm not an expert. Certainly I'm not, your application may be unaware of that. So the APM based telemetry might not pick it up. I don't know. But I just thought it was a really interesting opportunity to kind of make things a lot simpler. Yeah, great work. Sorry, I'll let you continue. Sorry, just one last question for you. Can you offer a quick word on how agent upgrades are rolled out? New application release required in order to update the agent? Or you were saying that actually you can just push the plugins dynamically. So do you therefore just update the configuration store, and then that will automatically propagate down to each and every agent?
Okay. I think it's a very complicated topic. Okay, so how can I say that? So can I just go ahead and introduce this slide first?
Yes,
okay. Okay, so how Sermant works in Kubernetes, I think so firstly, Sermant can be very easily integrated in Kubernetes with these microservice applications. But I think the theory, the basic theory is very simple, just like Envoy. Okay, just like Envoy. The only difference is that we for the init container, we do not stop we just put the Sermant agent image in the init container and put the system environment, okay, in the application container, so that the application container can be started up with this Java agent. So I think the fundamental theory is very similar to the Envoy. The only exception is that we do not start a standalone process. Okay, so that's a basic theory. So if every time the customer want to get a new release of Sermant agent in order to upgrade their service function, then I think once again they just need to update this this YAML file. Okay, so and now going to your questions. So the reason why we are having this dynamic plugin update things is because of very interesting scenario, which is called chaos engineering. So for this scenario, it's just unlike normal service governance. So the people, also the admins, they use so they put so they put this plugin there and do the chaos engineering to to inject an error to see if the application still works fine. And after the test, then there is no reason that the plugin is still there, right? So they will just turn it off. So that's why we have this function. I think the basic theory is that in the Java agent area, there are two ways of intercept to do the code enhancement. One way we call pre-main, and the other way we call agent main. In the agent main area, the Java itself provide a mechanism that you can dynamically do the code enhancement. So that's why we just leverage this Java's function to do that. That's a basic theory behind. But of course, you have to you have to do a lot of other code in order to get this function. So what we did is that we just we put a RESTful API in the Sermant agent. Then currently the function is that we are able to execute another Java process to ask this Java process to do the agent main code instrument in order to dynamically turn on and turn off the plugin. I think that's a basic theory. I'm not sure if I answer your question very clearly, but that's a basic theory.
One of the things I really find that you come across quite frequently is around the maintenance with service mesh is might not be everybody's initial top of mind hope, but after they've been running service mesh in production, it generally is their primary concern. How do you keep things updated whenever you have to update? For example, if you want to bump update Envoy proxy to a point release, I now have to do a rolling update on what could be thousands of pods inside of my service mesh. Obviously, there's different patterns which can make that problem smaller or larger. But the sort of the approach you were talking about conceptually about, for example, do I need to update the entire Envoy proxy? Do I only need to update a component of it? Well, if I add a new feature to load balancing, and then that's a load balancing function, which can then be sort of dynamically pushed into each of the agents. I don't need to restart or re-roll any of my pods. It makes the maintenance far more straightforward. That was kind of what I was digging into.
Yeah. Okay. Okay. So yeah. So that's a basic series. So now, okay. So should we proceed? Okay.
Please, thank you.
Okay. Okay, so here we list some of the supported product and provided features. So because we basically use a Java agent. So in Java we basically we need to support several framework. Okay, instead of just talking about like HTTP or whatever function. So that we just listed some here, like Spring Boot, Servlet, Jetty, Tomcat, blah blah blah. And for the configuration product, okay, so I think previously when we started this project, of course we have our native protocol for the similar configuration. So for each plugin, we allow the plugin to define the configuration by just using the JSON JSON format. Then we just store the JSON format in JSON content in the Narcos or Zookeeper or whatever, so that the plugin can be updated dynamically. And then later on, we just support XDS API, so that so that this plugin can work fine with the ISTO. Okay, so features. Okay, we can do basic service discovery and configuration, and we can also do like a flow control and grids for startup and shutdown, and things like that. And for the traffic management, we can do a load balancing and tag-based routing. That's what we just talked about. And we are also able to carry this tag through the microservices and one by one. Okay. And the observability, we are able to support the service matrix monitoring with a basic matrix monitoring. Okay. And other miscellaneous functions, prohibition for database write. I think these functions are very interesting. I'm not going to expand in details because of the time issue. But I just want to give you a very brief introduction that why we are having this is just because of some of the multi active scenario. Like we have a different data centers, right? We have a different databases, and some of the database in this data center are handling some of the business. Both of these the database are handling the business, but just some of them are handling the write, and another data center is handling the read and the write. Sorry. So some are handling the read, and some are handling both read and write. So for the only read only data center, we will apply this feature to make sure that these two data centers do not write the data to the database at the same time in order to keep the data consistency. So that's what this basically do.
Yeah. Okay. So when in the instance, which is quite common with databases, that you have read replicas and write write master, you don't need to directly configure the application to understand that logic. Sermant can be configured with policy, and Sermant understands that, hey, this is an insert statement, therefore that request should be directed to this particular database connection to the write replica. And if it is a select statement, then it needs to come from the read replica, and you can do that automatically without the need for any code level change.
Sort of, but it's not exactly the problem. So what I'm talking about is that so we have two databases. We have two cluster of the databases in two different data centers, and these two clusters of database, they will replicate the data to each other. Okay, so they have the same data. and because of kind of multi-active reasons, and also for the disaster recovery, disaster protection reasons. So we will deploy 2 applications in 2 different centers, and these 2 different centers, have 2 clusters of database with the same data. But in order to keep these data centers for the data consistency, so only one data center can do the right things. So this architecture is actually very popular here in China, especially for some large internet company. So what they do is that they will control the workflow at the beginning of this application gateway, to make sure that the right workload will route it to the right data center, to make sure that the right workload do not go to the real data center. But what we do more is that once the workflow goes anything wrong, this prohibition for the data writer is kind of a last resort, or the last fence, to make sure that the data does not go wrong, don't go to the wrong database. Okay, I'm not sure if
I do. I think I understand, and I'll let you continue. But if you have time, I'd love a separate presentation to the group on that architectural pattern, because I think folks will find that really interesting. But
okay,
yeah, let's continue. Sorry, thank you very much.
Okay.
Oh, sorry, bear with me, just in case you haven't seen it. There is one more question. I'm just scrolling back. So Mariano was asking, because of the XDS integration, does that mean that you're going to support all of the kind of the Istio features? So if I support an Istio service definition, which has sort of routing on it, will you be able to will your load balancer be able to interpret that? Obviously assuming that Istio is translating that into standard XDS calls.
Yes, that's our plan. Yes, that's our plan. So okay, so here our roadmap. So today we just do the initial support for XDS portal for source discovery, route and load balancing. So today we are able to do this. So we have 2 services deployed in the same Kubernetes cluster and listen to the same Istio. So some of these services can be deployed with Envoy, and some of them can be handled with a similar agent, and these 2 services can talk to each other. So that's what we basically do today for this service discovery and route and load balancing. And so that's our future, that we will do more things to do more comprehensive support for XDS protocols. So basically we want to just implement a full set of this XDS protocol, but for which part to go first, then we will listen to the community's requirement. We will listen to a community.
Oh, interesting. And do you currently support? Forgive me if I've been taking notes. So forgive me if I've missed the detail. Do you currently support MTLS around service-to-service communication? So for the example you gave, where you kind of have an Istio service which is talking via an Envoy proxy to a Sermant sort of Java agent, can that actually be MTLS enabled right now, or would that have to be just plain traffic between Envoy and Sermant?
So I'm not quite following the question. So your question is that
yeah. So if you're implementing like I don't know what it's called in terms of Istio, but the policy which basically configures the Envoy proxy to use mutual TLS. when a one Envoy proxy in Istio talks to another Envoy proxy, it would obviously make an MTLS request. The receiving proxy would validate the certificate, etc., and check the policy allow list to make sure that that connection is allowed. Do you implement that sort of the actual
Oh, you mean for the secure?
Yeah, the protocol encryption and the policy evaluation, or is that something? Because it's not a criticism.
You mean for the security reason, right?
Yeah.
We haven't done that. Just for information, we haven't done that yet. But if this with a high priority, well, I think we can do this year.
That's really cool.
Just naturally, it's in our plan. Okay, it's in our plan.
And on that topic, and I will allow you to continue because it is relevant as well. Have you spoken to anybody on the Istio team about the work you're doing around this? Because I think they would be very interested to chat with you.
Okay, not yet.
Not yet. Okay.
You guys are the first one
on a note to make that introduction for you.
Okay.
Please, sorry.
Okay, so yeah, so just to let you know why we are doing this is because we have a lot of customer here in China that that want us to implement this. But some of the customer, because they are inside of this IT department, so because this is a whole architecture inside of the IT itself, so not so many customer they put this security issue inside of the cluster as a priority one thing. So that's why we haven't implement this feature. But what does it do? Us want to implement it is that just the Envoy is able to talk with someone because in the typical customer environment, as I said before, just most of the applications are written in Java. But just for some reasons, because for some performance reason or for some legacy reasons, some of the applications are not written in Java. So in order to make this tool can talk, and so that's why they have to choose Envoy, for this legacy application or like some other applications that are not written in Java. So that's why because they are using Envoy and with the XDS protocol. So that's why we have to implement the similar agent that so that these two agents can talk to each other. Okay. Okay, so that's our adopters. We have already several adopters here in China. But basically they are from multi industries. Some of them are from ICT, and some are from e-commerce, financial service, mobile games. So come from anywhere. So basically, if they are adopting cloud native architecture and the application are written in Java, then there is a chance that they can use the Sermant. So our current stage is that we have a very good influence in China. In past 2 years, we made some conference speech, 3 or 4 conference speech in China, and get very heavily used in some of our community users. And our next stage is that we are trying to make the Sermant a global wide project in order to benefit more cloud native application developers. That's why we want to introduce this project into CNCF's Sandbox. Okay. Another use case sample, practicing end-to-end gray release, which I think we talked about this before, so I'm going to pass this. Community, we have our official website URL, which I list here, and we have 3 repository, Sermant itself and some website, which we locate our website here. So we will also have a similar example to help our customer quickly adopt this project. Get start more than 1,000. We have contributors from different companies and organizations. Some of them are from universities. Currently, maintainers are 4 from Huawei, and non-Huawei, two non-Huawei candidates are coming. Okay, license Apache 2 license. Okay, that's a brief introduction. And roadmap, I think I just talk about with this. So so basically, we done a lot of initial development, in last 2 years, and this year we just support XDS protocol for service discovery, route and load balancing, and next year we are going to do more comprehensive support for XDS protocol. And okay, that's basic information, and I think that's all. Okay.
Thank you. You know, I made a prediction that this was going to be fascinating.
Oh,
I'm happy to say that I was, as usual, correct. It was fascinating. Thank you.
We're delighted to hear that.
Thank you very much. It's really great project. I mean, really, really, really lovely project. I love what you're trying to achieve with the project. I love the fact that you're already sort of thinking about the integrations with existing service meshes and things like that. Very, very well thought out. Really, really lovely. I'm also very excited to send this over to my friend Daniel Bryant, who's a huge Java nerd, and I think he'll be very, very interested to see the approach you're using as well. I think you'll like it very much. We are at time, and I don't want to keep people, but I would, if you're free in a couple of weeks for our next we could call. I understand it's really late for you all, but I'd love you to come back and to chat with us some more about this and with some answers, maybe some further questions that folks may have once they've reviewed the videos and stuff like that. I would certainly love that. I'd love to chat you some more. We will get all of the information that I've started to type up in some notes in the project review. I'll get that typed up into a little bit more, well, tidied up. And I'll send you over a link to that so that you can just make sure that I haven't made any mistakes there. But then I'll also add that information to the Sandbox review link, because its intention is to help the TOC to be able to expedite the application for Sandbox. So we'll get that done. We as kind of a tag will also have a chat about the project, stuff like that. But I love what you're doing so far. And we would be very glad to help you with your application process and to make sure that things go as smoothly as possible.
Okay, thanks. So I'm very pleased to hear that. So I cannot wait to work with you to make this project go to a CNCF Sandbox. Thanks very much.
Oh, awesome. No, thank you. And to echo Lee's point, there's no it's not a small amount of effort to put together a presentation like this. So we really appreciate you doing that. We all understand how hard it is to try and get stuff around the day job as well. So thank you so much all for your time, and thank you so much for staying up so late as well. It must be like 1 a.m. now, so it's getting super late.
Amanda, thank you all. I think this project is very important to us.
Good. It's a great project. You should give yourselves a pat on the back.
Yeah,
all right.
Should.
Okay.
Now, so I will just very, very briefly, if anybody has any last questions before we do drop. If not, we can continue the discourse in the Tag Network channel asynchronously on Slack and also on the issue board. We will get all of those details in the recording for folks who've not being able to access the Zoom chat and who maybe are watching tomorrow and things like that. But again, I want to say thank you very much. Thank you everybody for joining us today. I hope it's been interesting. I've learned a lot. It's a pleasure to see you all. And I'm going to look forward to seeing you all again in 2 weeks.
Okay. Thank you. See you
Bye,
then.
guys.
Bye-bye.
Bye.
See you.